Uniform electric field. Up until now, we've dealt with electric fields due to individual charges. What is more interesting and relates to practical applications is when you have configurations of a massive amount of charges. Let's begin by examining two infinite planes of charge that are separated by a small distance. The planes have equal amounts of charge, with one plate being positively charged and the other negatively. The above is a representation of two infinite planes. It is found that the strength of the electric field will be uniform between the planes. It will have the same value everywhere between the planes. And the electric field outside the two planes will be zero. A positive charge placed within the field will move from top to bottom in the direction of the electric field lines. Point charges have a non-uniform field strength since the field weakens with distance. However, uniform fields have the same strength everywhere in between the plates. Only some equations we will learn will apply to uniform electric fields. These two equations here, they have K in them. Use these only with point charges. So remember, equations with K are for point charges only. This equation, that electric field equals the electric force per charge, it can be used in any situation, including uniform electric fields. In problems with uniform electric fields, you can usually assume there are no gravitational forces. This is because on the small scale, electric forces are much, much stronger than gravitational forces. Which of the particles, proton, neutron, or electron, experiences the most electric force? What about the least? Assume no gravitational forces. So which of these particles experiences the most and the least electric force? Well, since force equals charge times electric field, and the electric field is the same for all of the particles, whichever has the largest charge will feel the greatest force. The proton and the electron have the same magnitude of charge, so they will experience the same force, however, in opposite directions. The neutron has no charge and will therefore experience no force.
Alright, so now that we know they experience the same force but in opposite directions, which of these particles experiences the greatest acceleration? Well, remember, acceleration equals net force over mass. So mass and acceleration are inversely proportional. The forces on the proton and electron are the same. However, the proton is much more massive. Therefore, the electron will have a greater acceleration. So if your mass is smaller, your acceleration increases. These are inversely proportional. Here's another problem. We'll assume no gravitational forces. Which of these electrons experiences the greatest electric force? Which one experiences the least? Since this is a uniform electric field and they all have the same charge, they will all experience the same electric force. Remember, electric field equals force per charge. Therefore, force equals charge times electric field. All of these are electrons, so they all have the same charge. They're all inside of a uniform electric field. They all have the same field. So the field lines point like this, straight across from positive to negative. But since these are electrons, they're going to want to accelerate the other direction against the field. Assume no gravitational forces. All three electrons are the same distance from both plates, but they have different initial velocities. Which of the electrons will hit the plate first? Alright, so all three of these are electrons, and they're all in a uniform electric field, which means they will all feel the same electric force. And as we know, acceleration is net force over mass. They all have the same mass. They all have the same force. They will all experience the same acceleration in the same direction, towards the positive plate. So they're all going to feel a force this way. Same magnitude, same direction. However, since C is already moving in that direction, it will reach the plate first. B has to accelerate from rest, so it will strike the plate second. Over here we have A. A has to slow down, stop, and then start accelerating the other direction, so it will reach the plate last.